take a look at the sample test. Now, I'm asking you to do one of these problems substitution. Well, every problem might have substitution in it, but one of them by parts, one of them by partial fractions, and one by trig sub, one using table. I would first choose one that you think can do trig sub and by partial fractions. One of those two first, maybe parts also, but those are the ones that you want to be able to find. Tables you can use on a lot of different ones. So let's look at these. Let's see. By partial fractions, I want to be able to factor the denominator and make fractions out of it. Well, no denominators that factor here except for this one. So this looks like it's my partial fraction option. So I'm marking that. So I'm going to do this one by partial fractions. So let's see. Now I need to do maybe a trig sub. Well, the trig sub involves those things that look like square root of x squared plus a squared, or square root of a squared minus x squared, or the square root of x squared minus a squared, or maybe those things squared. I don't see that in here. I don't see it in here. I see it here, but I don't see it here or here. So this one probably is my trig sub problem. Then, let's see, parts. That's where we have to do the table with u and v. And so we want to be able to split the integral into two parts. And which one looks like that? Well, I'm thinking this one does. And if I let u be this and take the derivative, I might have to do it twice to go from x squared to x to no x's. So I might have to do integration by parts twice. But that looks like parts. So then one of these should be easy enough to do with just a simple substitution. Well, now if I look at this one, I could let u be the tangent. Its derivative is secant squared, and that would cancel the secant squared. So I think this one might be my u substitution. Although I might be able to do it on this one, I might let u be, say, sine of x, or cosine of x, and then the derivative would be sine, and that would cancel one of the sines, and I have sine squared, which would be 1 minus cosine. I could do it here, but I'm not sure I'd find a table formula for that. But I think that one is on my tables, and by the way, this is the table I will give you. I've added the problems in the appendix on this online book. But where we have sine to the third and cosine to the second, looks like we might be using one of these two reduction formulas. So I'm going to use the table on this one, and I'll figure out which formula here, the number of it, in a moment. So I think I've got a plan made up for doing my first 5 problems. That's the first thing you want to do when you're taking this test, is make a plan. If this is a good plan, you'll get points for making these choices. So if I do substitution, on this one I would let u equal the tangent of x, du would equal secant squared x dx, and so this would become the integral of secant squared x over u, and the dx becomes du over secant squared x. The secant squareds cancel. I have 1 over u, which is antiderivative is ln of u, and u was tangent x, and I'm done with that one. Partial fraction. Let's see, I think this factors to, let's see, x minus 2 and x minus 3. Two nice, simple, easy linear factors. So this is going to be the antiderivative of a over x minus 2 plus b over x minus 3, or vice versa. So this one's going to have to be times x minus 3. This one times x minus 2. And so I'm only going to have x's and a constant. My x's, I'm going to have 2 x's here, and I'm going to have a x's, a plus b. So a plus b has to equal 2. And for the constant, minus 3 has to equal negative 3a minus 2b. Well, this is simple enough to solve. I'll just multiply by 2 on this, so it'd be 4 equals 2a plus 2b. I add these, the b's cancel out, and I get negative 1a equals 1. So a is minus 1. And if a is minus 1, and we have to add up to 2 with b, b must be 3. So this becomes, pull the a out, be minus 1 over u, so that's ln of x minus 2, and then plus, pull the 3 out, 3 ln of x minus 3. Look at that. I'm doing it in this small space. Now, I will give you close to a half a page for each one of these. So you're going to have more room than this. But I'm able to get it in here. This one, and this is a definite integral, so I'll be easy to check my answer because it's going to be something. But let's get the exact. So I said trig sub, so I'm going to show this, even though I could do this on my calculator. I'm going to do the trig sub, and so I want to make a triangle. This might be a little tight. I might have to go to a paper on this. So it's got to be there. That's the plus 1, so that's got to be 3 on the hypotenuse. And it's subtract, so I think that's the sine. So I put 2x here, theta here. And so this side would be 3 minus 4x squared. So I have sine of theta is 2x over 3. So take the derivative, cosine of theta d theta is 2/3 dx. And I have to have an expression for that square root. So I'll do cosine, because that'll put that in the numerator. The cosine of theta would be that square root of, 9. 9 minus 4x squared divided by 3. And so now this integral becomes, I'm changing variables, so it's not 0 to 1 anymore. Let's see, dx is cosine theta d theta times, this is 2/3, so it'd be times 3 halves. 3 halves when I solve for dx. So I take that out over this denominator, which is, put the 3 over 3 cosine theta. Looks like the cosine thetas are going to cancel. The 3 will come out and cancel the 3, so I'm just going to get 1/2 integral of theta, not even theta, d theta, 1 d theta, which is 1/2 theta. And we still don't know our limits because we're in theta. So evaluated from something to something. Now theta is, let's see, that would be arc sine. 1/2. Solve for the theta, I'd have to do the arc sine of both sides. Of 2x over 3. Now I can go to my units from 0 to 1, and I can type those into my calculator and get 1/2 arc sine of 2/3, putting in 1, minus arc sine of 0. So, turn my calculator on, 0.5 parenthesis arc sine, second sine of 2 divided by 3, close parenthesis, minus arc sine 0, close parenthesis, enter. Now let's just check it. Go to y equals, clear, and it's 1 divided by the square root of 9 minus 4x squared. Graph. And we're supposed to find the area between 0 and 1. That's not a very big spot there. So, second, calculate 7 between 0 and 1, and it says it should be 0.364863. And going back to my 0.364863. So we've got the right answer. There's the exact answer. All right, by parts. And I think I'm going to have to do this one twice. So I'm going to pull out some paper here so it's not so crowded. So we have the integral of x squared e to the x dx, and so I'm going to let u equal the x squared because I want to take the derivative of it. E to the x dx here, integrated is e to the x, that's under the v. And the derivative is 2x dx, so this becomes uv minus the integral of u prime v, which is 2x e to the x dx. And then I'll do this again, uv and f prime, and now I'm going to put I can pull the 2 out, so I'll just put x and e to the x dx, antiderivative, e to the x, derivative is dx, so this becomes, that stays, x squared e to the x minus 2 times everything I get here, and the uv is x e to the x minus the antiderivative of these two, which is e to the x dx. So that becomes x squared e to the x minus 2x e to the x plus 2, integral of this is e to the x plus c. I probably could have got that in there, but anyway. All right. Leaves only this one. And I'm going to pull up the table here, and I'm going to see if I can get this so you can see it. Let's write on the bottom of this page, it's the integral of sine cubed x cosine squared x dx. And I'm going to use, let's see, if I use the top one, that would change the cosine from 2 to 0, so there wouldn't be any cosine left. Or if I use the second one, that would change the sign from 3 to 1. I kind of like that one because then I can do u sub and finish it and not have to do one of these again. It wouldn't be hard to do it again, but I'm going to do 12. So I'm going to choose 12, so I'm going to mark 12 is what I'm going to use. And number 12, we'll change this to, let's see, get it right here. Okay, so m is 3, so 3 minus 1 is sine squared x, and add 1, so cosine to the third to the n, x, over m plus n, which is 3 plus 2, 5, plus, oh, and it's minus in front of that, don't forget your minus, plus m minus 1, so that'd be 3 minus 1, 2, over m plus n, that's 5, antiderivative, sine reduced by 2 would be sine x, the cosine squared stays the same, dx, and now I can let u equal cosine x, du would be negative sine x dx, and so this part, I have all this, but this part would change to 2/5 antiderivative. We'd have, I let u be cosine, so I have sine x left. Cosine would be u squared, and the dx would be du over negative sine. And so the signs cancel, and the negative comes out. And the integral of u squared is 1/3 u to the third. So I get, for my answer, I'm going to have to work up here because I'm at the bottom of the page here. So I'm going to have this minus sine squared x cosine to the third x over 5 minus 2/5. This would be u to the third times 1/3, so that's 2/15. U to the third would be cosine to the third x plus c. So that's my answer for this one using tables. Now I have, going on, number 6. So if you're taking the derivative of an antiderivative, they're going to pretty much cancel out, and if this is just a plain x, you just put x in place of the t's. If it was x to the third, you'd have to take the derivative of this because of the chain rule. So the answer to A is simply e to the x squared sine x, and the derivative of the integral, there isn't a plus c, and one thing we do know about this one is, no, we don't know. That's it. That's what this works out to be. Now, if we have the derivative of then the and then do the antiderivative, then there is a constant. So I'm just going to say this is the derivative, f of t. F of t, capital F of t. So then the derivative would make it f prime of t dt, which I'd have to integrate from 3 to x. Now to integrate this, I'd have to find the antiderivative of f prime. Well, that's this. So that's e to the t squared sine t, and I'd have to evaluate it from 3 to x. So I'd have to put x in it like I did before, and I get e to the x squared sine x minus, and then I got to put 3 into it, so I get e to the 9, 3 squared, sine of 3. So that's what I get from this one, from B, and this is what I get from A. And number 7. Okay, so I'm going to have to figure out what's going on here. So this is 6, so this is 3. So the square is 3 high, 2 wide, so each one's worth 6. And I'm going to look here, and I got 1, 2 squared, so that's 12, and it's negative. Oh, but I said at 3, I have to be at 0. 2, 4, at 3, it's 0. So I need to work from there. So here's 3. How much more do I have over here? Well, let's take a look at this. It's about there, so it's not quite a full. And so this is 3, so this might be 1, this might be 2 high by 3 wide. So that's 6.5. So this must be 3, and it's negative 3. So I'm going down 3 by 6. So I'm going to make this just be the same scale, minus 3. So I got to go down 3 by 6, and it's a positive slope, so it's concaved up, and that's going to be the minimum. And then here I have 3 high, 4 wide, so that's 12.5, 6, so I got to go up 6, so that would take me up to positive 3, still concaved up. Okay, now what happens here? Well, this is negative, so I'm still going down. I'll work from here to here, so that's from minus 1 to 3, that's 4 wide. And the height here is minus 6. The height here is minus 2, I'm saying. So that's an average of minus 4 plus minus 2 plus minus 2, minus 6 is minus 8.5 is minus 4. That's an average of minus 4 times 4 is minus 16. So I got to go up 16. So here's 3, 6, 9, 12. So I've got to come down 16. So I probably have a bad scale here, but it's 16. By the time I get to minus 1, I got to be up about here. Chose a not so nice scale, and it's still curved up. And then I have to go down some more. So let's say that's 2 wide and 4. 2 by 4, no, 2 by 6 is 12 divided by 2 is 6. So I got to go 6 higher, which should take me about to there when I reach my peak at minus 5. 2, 4, 5, that should be at my peak. And then I go I was going up from here to here, so this I have to come down this area, and that looks like from, I'll just round it off, to 4 by 3 is 12.5 is 6, so I got to come back down 6, and that's got to be concave, and then it's 0, so then it's got to go this way, and then I've got to go, since this is negative, it has to be coming down, so I need to change my scale. But you get the idea of how you got to do this. If you chose a scale that was off like this, that'll be okay. And if it runs up here, that's okay. I'll give you more room, bigger graphs on the test. That's the idea.